Hello once again, my children. We're looking at the second part of dihybrid crosses. And as you would have noted by now, it is a little complicated, but the minute you start writing, it becomes easier. So I hope that you have a page and pen in front of you, and as I'm speaking, you are writing. I will try and write along with you as well. Okay? So let's look at the first example. In pea plants, let's see if I can make this a little bigger. Don't think so. I'll learn a little bit more. In pea plants, the allele for tall plants, for tallness, is dominant over the allele for shortness. So shortness is recessive. So if I'm showing a tall plant, I can therefore show a tall plant using capital T, or capital T, small t. But I'm not just showing a tall plant because there's another characteristic I have to worry about. The allele for purple flowers is dominant over the allele for white flowers. So purple I can show using capital T, capital P, or capital P, small p. Okay, so very, very importantly now, both these characteristics go together. You can either be tall and purple or tall and white. You can be short and purple or short and white. 4 different phenotypes. 4 different phenotypes. Once again, both the dominant characteristics, tall and purple. One dominant and one recessive, tall and white. Tall being dominant, white being recessive. Or short being recessive and purple, short and purple. So tall and white or short and purple, or 2 recessives, short and white. 4 possible phenotypes. Okay, 4 possible phenotypes. Now they say to you, 2 plants heterozygous for both tallness and purple flowers were crossed. Heterozygous means having 2 different alleles, 2 different alleles. So how would I draw heterozygous? In your mind, you should know already about this. You should know already how I'm going to draw heterozygous because I must have 2 different alleles for both. So it'll be capital T, small t, capital P, small p. You with me? Yeah. And cross what? Because I want to have both parents, isn't it? So both of them as the parents. So capital T, small t, capital P, small p, cross. What's the other parent looking like? The other parent is looking like, both of them are heterozygous. There we go. That's what my parents look like. And then I'm going to try and work out the gametes from each one, isn't it? So, and we worked it out the last time by using your Punnett square. So first of all, they say to you what to do generally, identify the phenotypes. So we did this. Choose letters to represent, we've done it. Write out the genotypes of each parent, we've done it. Okay. Let's see what's the next thing they're ordering us about. Determine the possible gametes for each parent. Remember that each parent will have 2 alleles for each gene. Are you with me? And the gametes for each parent will therefore have 1 allele for each gene because of segregation. Remember that because of the principle of independent assortment, an allele for one gene could appear in the same gamete with any of the alleles for the other gene. In other words, we say they both separate out and they'll go out separately into the gametes, as well as they separate independently of the other one. So you will have 1 allele for one characteristic and another allele for the other characteristic. Good. So there we see, papas, this is how you work out the gametes. You put your capital T, small t on one side, there, your capital P, small p on the other side, and these are the 4 possible gametes. This is the only genotype that can give you 4 possible gametes. Other genotypes give you like 2 different gametes, etc. But this gives you 4 possible gametes, so therefore it gives you the largest variety. I always told you heterozygous gives you the largest variety. So Enter the possible gametes at the top and side of a Punnett square. This is how you're going to find out what your children are going to look like. We don't say children, your offspring. Okay, so there we go, babies. P1, they will never ask you to do a complete cross in dihybrid crosses, but they'll ask you to fill in things or write down the genotype, etc. So there we go, P1, they'll never ask you to do this, but they're just showing this to you. Tall and purple cross tall and purple. Genotype, both of them were heterozygous for each characteristic. Now, you take the gametes, these were the gametes that we worked out, capital T, capital P, and etc. Put it on one side there, and that is as identical gametes here, put it on the other side. And then you do as we did before. If that gamete met that gamete, this is what you'd have. If that met that, that is what you'd have. If that met that, that is what you'd have. And if that met that, that is what you'd have. So in a question like this, they normally may leave out one. They may normally leave out one of these here. Okay. And for example, they could leave out this one. And they'll say to you, okay, work out the genotype of that particular offspring. So it'll be that cross that, and you get that. So you put your T's together and you put your P's together. So if you decided to start up with T's, then every genotype you will show using your T's in the beginning. And once you finish this, you would realize that you get the phenotypic ratio 9:3:3:1. Remember, there are 16. 9 out of the 16 would have both the dominant characteristics, that is, both tall and purple. Look at this. 1 tall and purple, 2 tall and purple, 3 tall and purple, 4 tall and purple, 5 tall and purple, no, you're not. 6 tall and purple, no, you're not. 7 tall and purple, 8 tall and purple, no, you're not. No, you're not. 9 tall and purple, no, you're not. No, you're not. No, you're not. So you got 9 tall and purple, 9 with both the dominant. And as you go through it, you find that you will have 3 of them, which will be 1 dominant, 1 recessive. So 3 of them would be tall and white. The other 3 would be short and purple. And only 1 would be short and white. So therefore you get the ratio 9:3:3:1. So 1 out of the 16, there's a 1 out of 16 possibility that they could be short and white, both the recessive characteristics. Okay, so there we go. 9 different genotypes in the diagram above. So if you look at the genotypes there, 9 different genotypes, but there are 4 different phenotypes. 9 of them being tall and purple, 3 short and purple, 3 tall and white, 1. So 9:3:3:1. The only way to become an expert is this is by looking at questions. So let's look at one question before we close up. Okay. Here's a cutie little thing here. Hamster. In hamsters, the allele for black coat color is dominant over the allele for white coat color. And the allele for rough coat is dominant over smooth coat. So the 2 characteristics are color and texture of coat. Color can either be black or white, with black being dominant. Texture of coat could either be rough or smooth, with rough being dominant. You got that so far? If you cross a hamster that is heterozygous black and homozygous rough, let's look at it. Heterozygous black, 2 different alleles, can only be one thing, isn't that so? Black is dominant, heterozygous. And homozygous, what do they say? Rough, which is dominant, rough. So there's only way to show homozygous. There we go. So that's one parent. If you cross that parent with one that is heterozygous black and heterozygous rough, oh, we should know heterozygous black and heterozygous rough, black and rough are dominant. So, is that it? So that is one parent, that is another parent. don't, if you cross them now. Okay? So what are they asking you? What will be the phenotypes and genotypes of offspring? Oh my God, they will never ask you to do this full cross, my darling, so don't ever be scared. But you can work out the gametes in this here. You know, let me just erase this so it doesn't get to your heads. You know? So there's your heterozygous black, homozygous rough, heterozygous black, heterozygous rough. And those are the possible gametes, my darlings, from that one. Is it from that one? Let's see. Capital B, capital R, capital B, capital R. So if that one met that one, it will come out in a gamete. If those two come out in a gamete, if those two come out in a gamete, if those two come out. And the same thing over there. And you get, notice you are not both heterozygous, so you got two types of gametes there. Remember I told you to have 4 types of gametes, you got to be heterozygous for both. Okay, and that is it. So there are several questions on these. Make sure you go through these questions. And if you'd want me to, we will make a video doing one of those questions. God bless you until I meet you again.